So then that means I is bring over the 1, you get 0.0032737. Right, okay, 4. And then it says correct to 2 places decimals. So turn it back to a percentage. So to turn it back to a percentage, multiply by 100 and then round it up to 2 places decimals. So that would be 0.33%. Okay, is that right? Right, part 2 then. Part 2 is leave that there, so I'll probably need that 0.33. Right, the value of her savings at her 21st birthday. Right, okay, we don't actually need the monthly rate, do we? No, we can do it yearly. Right, that's exactly 3 years, isn't it? Okay, so it's €30 per month. Right, okay, so that's €30 for the first month. Right, okay, so she got, the last month she got that €30 was in for 1 month. Right, then the next one, the second last payment was in for 2 months. Then the very first payment she put in was, oh, I do need the monthly one, don't I? Sorry, don't mind me. Right, okay, so it's 1.0033. Is that okay? 1.0033. Okay, and the very first payment she put in was 1.0033, and that was in for 36 months, 3 years. Okay, is that right? Sorry, you can't see. Okay, is that right? So I wrote it backwards. So the very first payment, which I never put in, was in for 36 months. So she got 36 months interest on that. The very last payment was in for 1 month, so she got 1 month's interest on that. Okay, right, so to find out how much she has, we get Sn. So Sn is A times 1 minus r to the power of n all over 1 minus r. So Sn A is the first term, which is 30 multiplied by 1.0033. The second one is R is you're multiplying by 1.0033 each time, and there's 36 terms in the sequence, so that's to the power of 36 all over 1 minus 1.0033 into the calculator with that and press equals. I'll leave you do that bit. Okay, that's alright. Okay, is that okay? Right, I wrote the list backwards to start with. Okay, if you wanted to be picky, you could say, well, the first 30 was in for 36 months. The second €30 she saved was in for 35 months. And the last one she saved was only in for 1 month. So ... The last 30 was only in for 1 month. Okay, so technically it should be written backwards first if you're thinking about what actually happened. But I wrote it this way to start with. Is that right? Any questions? You're okay calculating that in the calculator yourselves, yeah? Yeah, thanks. Okay, thanks. That was number 2. I gave you number 3. Does anyone need me to do number 3? Yeah, number 3. So this is question 3, page 155. A special savings account offers an annual equivalent rate of 4% per annum. If I invest 2,000 at the beginning of each year for 5 years in this account, how much will my investment be worth at the end of the 5th year? Okay, so we can do yearly, right? Okay, so there's 5 years and it's 4%. Okay, and she's going to, 2,000 at the beginning of each year. So for the first year, right, the first 2,000 is going to be in for 5 years. Okay, the second 2,000 she puts in will be in for 4 years, right, and so on. I could nearly write them all out. The last 2,000 she puts in is only going to be in for 1 year. Okay, so that's an arithmetic sequence written backwards. Okay, so if you write it out forward, it's the last 2,000 was in for 1 year, right? The next 2,000 was in for 2 years. Okay, so I'm just writing it backwards, and the last one is 2,000 multiplied by 1.04 to the power of 5. So that's an arithmetic sequence, and you're multiplying by 1.04 every time. Okay, so A is the first term, which is 2,000 times 1.04, and R is what you're multiplying by, so you're multiplying by 1.04. Okay, so then you get Sn, so Sn equals A times 1 minus R to the power of n all over 1 minus R. So A is the first term, which is 2,000 multiplied by 1.04, and then I have 1 minus R is 1.04. N is the number of terms, so there's 5 terms in that sequence, to the power of 5 all over 1 minus 1.04, and I'm going to, you put that into the calculator exactly as you see it, you press equals. Okay, are we okay with number 3?
Yeah,
Questions?
thanks.
We're all okay with putting it into the calculator bit, yeah? Okay. And the last one you had was number 6. Am I doing number 6?
Yeah.
Right, okay. So, question 6. Right, Anne received a cheque in the post for 6,523.33. Okay, so that's what she ended up with. Okay, after saving a euros at the start of each year for 5 years, right, raising 9% per annum. Okay, so she did 5 years. So for the first A she put in, she got 5 years interest on it. Okay, for the second amount she put in, she got 4 years interest on it, right, and then all the way to the end. The last one, she got 1 year's interest on it because she put it in at the start of the year. She got a whole year's interest on it. Okay, write down a geometric series. Right, okay, so let's write it backwards. Okay, so the last one was in for 1 year. The second last one, it was in for 2 years. Right, and the very last one was in, or the very first one was in for 5 years. There's your geometric sequence or series, right? At the end, find the value of A. So for A is the first term, so that's capital A times 1.09. R is what I'm multiplying by. I'm multiplying by 1.09 every time. Okay, then Sn equals A times 1 minus R to the power of n all over 1 minus R. So fill in. So Sn is what you ended up with. We know the answer. So it's 6523.33. I know what I ended up with. A is the first term, which is capital A multiplied by 1.09. Then it's 1 minus R is 1.09. To the power of n is the number of terms in the sequence. There's 1 term for every year, so there's 5 terms. All over 1 minus 1.09. Now, to work all this out, put this much into the calculator. Okay, so I'll actually do this one. Right, okay, so I'm pressing, no, I'm not pressing that button, I'm pressing the fraction button first. Right, and I have 1.09 open bracket 1 minus 1.09 to the power of 5 uh, close bracket, underneath 1 minus 1.09. Okay, and when you work all that out, you'll get 6523.33 equals A multiplied by 6.5233, okay, and then divide, so you get A is equal to, right, okay, 6.53.33 divided by that equals 999.99. So that means, rounded up, it's 999. That's €1,000. So she basically saved €1,000 every year for 5 years, and that's what she ended up with. Is that alright? Okay, that was number 6. Right, the second part of this section, right, okay, is pensions. Okay, so let's clear off these. Sorry. Okay, so I have. Okay. Here we go. A load of writing for your notes there. Okay. Okay, so to calculate the sum of money needed to be invested now to guarantee a fixed pension payable over a number of years, we take the interest off the pension. Right, okay, so if I want to start getting my pension paid out tomorrow, and I want 25,000 starting tomorrow, right, paid out for the next 20 years, right, okay, or well, starting in 1 year's time, I want to put money into an account, and I'll call it my pension account, right? And I'm going to say, out of this account, I want you to take 25,000 every year and give it to me for the next 10 years, right? Okay, so if I want 25,000 for the next 10 years, girls, I don't need to have 250,000 saved, okay? Because 25,000 for 10 years is 250,000. So I don't need to have 250,000 saved, right? Because they're going to pay me interest, right? I'm going to have 250,000, right? Or I'm going to have a load of money inside an account. They're going to give me interest on it. So I can take the interest off that. So I don't need 250,000 saved, right? Okay? So we can save 250,000 less any interest the banks will give us. Okay? So if I want a pension of 25,000 for 10 years, now I know you'd want a pension for longer than that, but I just picked 10 years because it was easy to multiply, right? So 25 years, 25,000 for 10 years. That suggests that you need 250,000 in an account, but you don't, right? Okay, so in order to find out how much money you need in your account, we have to take the interest that they would give us, right? Because this would be in an account, right? Okay, for 10. I'll explain when I do the example in a second. It'd be easier when I get on to the next slide and I do the example. Okay. Okay, so if you just write that down, and then I'll move on to the next slide and I'll be able to explain it better. Right, are you ready? Am I okay? Yeah, thanks. Okay, we good? We're okay?
Just 1 sec, sorry.
Yeah, sorry, no, tell me when you're done and then I won't keep asking you.
Yeah.
Thanks.
Okay.
Right, okay, so I'm going to go straight to an example to try and explain it. Right, okay, so girls, what we're doing here now is we're not talking about saving for our pension. We're talking about we've got to the age of 65, we've got so much money in an account, right, and we want to know how much money do I need to have in that account in order to get a pension of 25,000 a year for 20 years, okay? So we're not talking about saving for the pension. That's different. That's my installments that I just did, right? Okay, we've got to the age of 65 or whatever age, right? Okay, and now I want to have a sum of money inside an account so that I'll be able to get 25,000 euros a year for 20 years, okay? Assuming an annual equivalent rate of 4%. So they're going to give me interest on 4%, okay? So basically, right, we're looking for the present value, as in today's money, right? How much do I need to have that in an account, right? I don't need to have 25,000 multiplied by 20 is 500,000. I do not need to have 500,000 in an account because they're going to give me interest on it. So I need 500,000 less the interest, okay? So what I have to do is, right, okay, the first 25,000 I get paid out, and if they don't say when they're paying it out, we're assuming it always assume the end of the year. So the first 25,000 they paid out, right, was in an account for a year, right, and they gave me 4% of it. So they gave me 4% of it. So I don't need to have saved 25,000. I need to take off the interest. So if I divide by 1.04, I'll find out how much exactly I need to save. So I'm just going to do that for a minute so I can explain. Right. Okay, that's 24,038 euros. So for my first 25,000, because they're going to give me 4% interest on it, I don't need to have saved 25,000. I need to have saved 24,038 euros. Okay, so that's what that is. For the second year, right, the second year they pay me out. They're going to pay me out the 25,000. But that's been in the account with them for 2 years. So I don't need to have saved that 25,000. I need to have saved that much, right? Because I can take 2 years interest off it. So you divide it by 1.04 to be squared to take 2 years interest off it. The third year, they pay me out at 25,000. I don't need to have saved 25,000 because I'm going to have 3 years interest on that. So I'm going to take off the 3 years interest. So now I'm taking off the interest to see how much money I have to have in the account. Okay, so before I was adding on the interest, now I'm taking off the interest because I want to know how much do I have to have in my account in order for them to pay me out, right? And the very last, and so on, all the way up to 20 years. So the very last payment of 25,000 is going to have 20 years. I'm going to have 20 years of interest on that. So I don't need to save all the 25,000. I just need to save. I can take off the 4% per year for 20 years to see how much that is. So I want to know how much I need to have in my pension account before they can start paying me out. So, but they're going to pay me interest on the money in the account. So I'm going to take off the interest off the money every year. So for 1 year, 2 years, 3 years, the last 25,000 is going to have 20 years interest on it. So I'm going to take 20 years interest off it to know how much I need to have in an account. Now this is a geometric series written forwards. I don't need, because it's starting with the smallest up to the biggest. Okay, A is the first term, which is 25,000 over 1.04. Or it's what I'm multiplying by. So, or this time I'm multiplying 1 over 1.04. So that's, if I multiply that term by that, I'll get that. Second term by 1 over 1.04, you get the third term, and so on. Right? So there's R, and that's my my R, right? So SN is how much money I'll need to have in that account at the very start. So SN equals A times 1 minus R to the power of N all over 1 minus R. So how much money do I need in my pension account at the start of my pension? So that's 25,000 divided by 1.04. That's what the first term is. 1 minus 1.1 over 1.04 all to the power of 20. There's 20 years, there's 20 terms in there, all over 1 minus 1 all over 1.04, and into the calculator with that. Right, okay, so give me a minute to put this in. So we have 25,000 over 1.04 multiplied by 1 minus, oh, what am I after doing? No, I'm after, sorry, just give me a sec here now because I typed it in wrong. 1 minus, open bracket, fraction button, 1 over 1.04. Oh, I never put anything up there. Right. Close bracket to the power of 20. You probably have this done 10 times over. I don't know what I'm doing here. 1 minus 1 all over 1.04 equals, right, I need to have in my pension account when I turn 65, I need to have 339,758 euros and 16 cents in my account. Okay? Right. Does that make sense to everyone? Not really, probably. Okay, so I'm not talking about saving for my pension. I'm actually talking about I'm at age 65, right? Okay, here's my pension account. I want it to start paying me out. So how much do I need to have in my pension account? So they pay me 25,000 euros for the next 20 years, and this is how much you need to have in your account, right? Okay, so between now and when I turn 65, I need to save this much, right? Okay, so we're not talking about saving it, we're talking about the paying out of it, okay? Because your money is I'm going to put that into an account at 4%, right? I'm going to take out 25,000 every year, but I'm still going to earn an interest on the balance, okay? So that's where that money came from, right? And this is sometimes called, girls, the present value. Right, the present value, right, the future value is 500,000 because that's how much I'm going to get paid out. The present value is how much it's worth at the start of the 20 years before they give me interest and start paying me out and stuff. Okay, is that alright? Are you all gone demented? Yeah. Or you're all well, one person is there anyway. Right, okay, example 2. I'll give you a chance to write it down and then I'll do it. Today is Sinead's 18th birthday. She received money presents totaling 300 euros. That's 300 euros. I thought she'd do better now for her 18th, but anyway. She is due to retire when she reaches age 65 and on this occasion will receive a lump sum of 150,000. Taking the annual interest rate to be 3%, find the present value of her 18th birthday present and find the present value of her retirement lump sum. Right, am I good?
No. No. Just one sec.
Yeah,
Sorry.
grand. No, take your time. It's just I don't know how long it takes to write. I know it took me ages to write it, but ready?
No. No.
Yeah. Now? Yeah.
Yeah, you can
Okay.
change them.
Right.
Yeah.
Okay. So basically, she got 300 euros on her 18th birthday. This is now. Right? Okay. So we want to know, right, how much she gotten 3% per year. Right? Okay. So we want to know how much does she have now. Right? Okay. So this is, what's it, 22 years ago? Right, that's 22 years ago. You want to know how much she has now, right? So that's just a case of final amount is equal to the principal times 1 plus I all to the power of time. So the final amount is equal to 300 times 1 plus 0.03 all to the power of 22 because it's 22 years later. Okay, so 300 multiplied by 1.03 to the power of 22 equals, right, €574 and 83 cents. Okay, that's all that bit is. Okay, and the other bit is working backwards. So she's on her 40th, right? Okay, and on her 65th, she wants 150,000. Okay, so this is where we are now. So we want to know, well, how much, but we know she's going to get 3% per year between now and when she's 65. Okay, so they want to know the present value, right, of how much is that 150,000 in this year's money. Okay, so she's going to get 3% per year. So that means the present value is equal to, it's the second formula in your book, 1 plus I all to the power of time. So it's 150,000 divided by 1 plus 0.03 all to the power of time. That's 25 years, isn't it? Okay, so into the calculator with that. So this example 2 was way easier than example 1. 150,000 divided by 1.03 to the power of 25 equals, that's 71,640 and 84 cents. So 71,640 and 84 cents. Sorry, you can't see that. Right, that's really badly written, sorry. $640. Okay, girls, there's not many pensions examples in the book, okay, but we'll be doing ones from exam papers next week, okay, so we'll get on to it then. So 7, 8, 9 and 11. So page 155, 7, 8, 9 and 11. Okay, so that's it. So once you've that down, you can head off. I'll see you tomorrow.